ET105 inductors, example 11.12. Here's the circuit, 12 volts, RL, and then switch is closed at time 0. It says determine tau. Tau equals L over R, 4.7 millihenries over 2.2K equals 2.14 microseconds. Write a mathematical expression for the current I sub L after the switch is closed at T0 seconds. Here's the formula for the storage. I sub L equals E over R times the quantity 1 minus E to the minus T over tau. E is 12, R is 2.2K. That's the total resistance. If there was more than one resistor in here, you'd have to, figure out what that is. So then it's 5.45 milliamps times 1 minus E to the minus T divided by 2.14 microseconds. Ridiculous. Write the mathematical expression for V sub L and V sub R after the switch is closed at T0. V sub L is this formula, so it would be 12 volts times E to the minus T divided by 2.14 microseconds. V sub R is just IR times R, which is IL times R, which is E times the quantity 1 minus E to the minus T over tau equals 12 volts times the quantity 1 minus E to the minus T divided by 2.14 microseconds. Determine I sub L and V sub L at time equal 1 tau, 3 tau, 5 tau. So you have to, for little t, it doesn't show it here, but you'd have to put in 1 tau in here. So the taus would cancel. This would be E to the minus 1 for this, and then E to the minus 3 for this, and E to the minus 5 for this. And the same thing goes for the voltage. You put your 12 times E to the minus T over tau. For 1 tau, this is 12 times E to the minus 1, which is that, and then 12 times E to the minus 3, which is this, 12 times E to the minus 5, which, as you can see, is almost 0. And then it says sketch the waveforms. So at time equals 0, the inductor's an open circuit. So the current's 0, and then it quickly climbs up at 5 tau, which is 107 or 10.7 microseconds, to 5.45 milliamps as shown here. And then V sub L, since it's open, starts off at E here. And then it decays down at 5 tau to 0. Now, the interesting thing here is if you put 0 in for T, you're going to get 12. And if you put 0 in T here, you're going to get 0, because this is 1 minus 1, which is 0 times that. So if these formulas work, they're pretty straightforward.